To import a Wintools project into ARCAD 4, start the ARCAD 4 client. Then create a new project. Click on the File menu and New Project. The default location for projects with ARCAD 4 is in c:/revcadw/projects. Inside this folder, make another subfolder for your project. And then navigate inside that folder and type the name of a project that you wish to create. Once this is done, your project is now loaded into the ARCAD 4 client. Now, to import the Wintools project, click on Utilities, Import, and Import Wintools Project. Navigate to the location on your hard drive where you have a Wintools project stored and select the project file. By doing so, this brings up the Wintools project import wizard. In the center section of this dialog box, on the left-hand side, all the available modules and operator consoles inside the Wintools project are indicated. Users can either add one or more, or even all of the items found in this side of the dialog box to the modules to import section. If you want to add everything that's inside the project, simply click on the Add All button. If you want to add just one node to it, select it and click the Add Node. But in this case, I'm going to add everything that's in there. And when you're satisfied with what you have in the Modules to Import section, click the Import Project button. This process copies the files located in the original Wintools file folder to your new ARCAD 4 file folder. This procedure can take anywhere from 30 seconds to 2 minutes to execute, depending upon the number of CAD files and operator displays. This project has approximately 2,200 CAD drawings in it, and I think there's about 350 displays. When you're finished, you can take a look and see what was imported by just selecting a module and seeing what the files are that show up on the right-hand side. If you want to take a look at any of the CAD drawings, select a module and double-click on the CAD drawing, and it'll activate the CAD editor. Now, before we really get into the meat of the ARCAD system, there's some databases that need to be set up. There are 4 main databases that you have to set up manually, and the first one is the cross-reference database. The cross-reference database is accessed by clicking on the cross-reference database button. The cross-reference database program comes up. Click on the Build Database tab, and then click on the Build Database button. Now, this procedure will start scanning all of the CAD drawings located in the project and create records for every single IREF, OREF, and IREFO that it encounters. This procedure can take anywhere from 30 seconds to 2 minutes to execute, depending upon the number of CAD drawings in the project. The cross-reference database will be used later on in the CAD editor when identifying a cross-reference bubble. Users can quickly hyperlink from one CAD drawing to another by identifying and looking at the item properties of any cross-reference bubble. Once the cross-reference database has finished, the database has been set up, and as you can see in this example, there are 29,158 records. There were some errors encountered as well too in this project. There were some unresolved IREFs. This is probably because this project hasn't been looked at carefully, and there are some unresolved errors. These can be quickly identified. Double click on them, it'll take you right to where these errors occur. And as we can see here, we've got some cross-reference bubbles inside a digital input over the bus block, and there's no cross-referencing descriptor text on any of these inputs. Close off the cross-reference database, and we're finished with that. The next database to set up is the function block database. The function block database is used to keep track of the location of every single function block in the project. Once again, click on the function block database button. This activates the function block database program. Click on the Build Database tab and click on the Build Database button. And once again, the software will scan every single CAD drawing in the project and start creating database records for every single function block that it encounters. This procedure can take anywhere from 30 seconds to 2 minutes to execute, depending upon the number of CAD drawings. Once you're finished, the database has been set up. Users can quickly go to and see which blocks they are by double-clicking on the entries in the database, and it'll take you right to the CAD drawing and zoom in on the block in question. Now we'll close off the function block database. We'll now activate the graphics database. The graphics database is used to identify the location of taggable entities found inside all the graphic display files, or DR files. To activate the graphics database, click on the graphics database button, and the principle is again the same. Click on the build database tab and click on the build database button. This procedure is extremely fast, taking under a minute to execute. 355 displays are being scanned here, and the database is set up. Once it's finished, as you can see in this example, there are 26,112 records. Now, the graphics database contains only entities that have tags associated with them. This includes static symbols, interactives, escapes, trends. Anything with a tag in it is located and stored in this database. Once we're finished, we can close that off. Now we're off to the very last database, and that's the tag database. The tag database is activated by clicking the tag database button, and this brings up the tag database program. Before we actually add tags to the tag database, we'll set up the engineering units and logic state descriptors. And to do that, click on the EU and LSD tab, and then you can import the information from CF files that are stored in your Wintools project or extracted from an operator console. To do that, click on the Setup and Import from CF file tab, and for the engineering units, we'll click on the Select Import File, navigate to where we have the Wintools project stored, and there are the files. I'll just select the EUD SCP file, which is the engineering units, and click the Import button. And when we're finished, we have the values stored inside. We'll do the same thing for the logic state descriptors, and click the Import button. And once again, we have all the entities now brought in from the for the engineering units and the logic state descriptors. Next thing you'll want to do is you'll want to set up the alarm comments. Click on the alarm comments tab, then click on the Setup Alarm Comments tab, and then click on the Select Import File. Once again, navigate to where your Wintools project is and select an alarm comment file and click the Import button. The alarm comments are read in and the database has been set up. Now the last part of this is the tag database. Now tag database information is extracted out of operator consoles in a TTG file format. ARCAD uses those TTG files as the source of the tag information. And with ARCAD you can import not just one TTG file but multiple TTG files into a segmented tag database. To do this, and I'm going to actually import 3 here for this example, click on the Build from TTG file. Now select the TTG files that you wish to add to the ARCAD tag database by clicking on the Add TTG file. Once again, you're going to have to navigate to where your Wintools project is stored on the hard drive and select your first TTG file. Now I should note for this demonstration that these are 3 TTG files that were extracted from 5,000 tag operator consoles, and to segment the database we're setting an offset value of 5,000. If I add a second TTG file, this offset value will become apparent because it will now offset all the tag indices in this next TTG file by 5,000. If I add a third TTG file, it will offset it by 10,000. Once we've selected the TTG files we wish to import, we click the Build Tag Database button. It'll then prompt you to say, hey, we're going to erase what's inside there. Click Yes, and off it goes. Now the procedure for reading them in will read the TTG files in sequentially, offset the tag indices, and set up the tag databases correctly. Then it scans the CAD drawings to find where the blocks are that are indicated in each record in the TTG files. Now you're going to see a lot of errors pop up in the build log section of this dialog box. This is normal because a lot of these errors are typically AOLs and DOL blocks, that being function codes 30 and 45, and those are typically used for inter-PCU communications in the Infi90 system. Just basically meaning that there's an AIL and a DIL in some module that's importing from an AOL or a DOL in some other module, and those blocks are, even though they're taggable, they're not located inside the tag database. As well too, you'll see other errors like these errors that have just been displayed here, which are showing that there is a tag record inside one of the TTG files, but there is no block located in any of the modules. This might be due to the fact that these are probably being imported from a third-party software server of some sort, such as a Pi server. And if you want to take a look at where these errors are coming from, in particular the ones that are coming in from AILs and DIL blocks, double-click on them. It'll take you right to where they are. And for this example here, this is an input that works with the advanced Harmony I/O blocks, but there is no tag associated with it. And now you have your TTG files imported, and you have now got a successful tag database. And here's the entries inside the tag database. For anyone who knows the contents of the tag database, these fields look exactly identical to what other Infi90 software is using, except that we are adding 5 additional fields in each record, one for the drawing, one for the X location in the drawing, one for the Y location in the drawing, the offset value that's used for the tag index, and the original TTG file that was used for that tag. So let's close off the tag database. Let's take a look at any CAD drawing here. Let's see if we've got a tag inside here. Yes, we do. If we want to see what the tag information is right from the CAD editor, identify the block, go to Item Properties, and you'll see a button here that says Edit Tag. That button only appears if the block is in the tag database or is taggable. Clicking it reveals all of the tag information. And unlike other software, you have access to all of the information found in all of the fields of the tag database that apply to this particular block. You're not limited to just the tag name and the tag description. If users wish to change the tag index of this block, click on this button here, and the tag index map will appear, showing you all the tag indices used for this particular TTG file. If you want to switch it to a different TTG file, you can click on the tabs at the bottom here, scroll back up, and assign it to a different index if you wish. But I'll just assign it to a new tag index here. Let me scroll down a bit, and I'll assign it at location 3400 by double-clicking in the field, and the new tag index is now 3400. And that was originally coming from God knows where, but maybe if it was here I can just put it back to that location right there. And as you can see, it's already brought it up to date. So that concludes this part of the demonstration on how to import Wintools projects. We'll get into more of the advanced editing features of ARCAD in a later demonstration.